Welcome to Wildcat Science with Mrs. Haugo. This is Chemistry, Chapter 5, and we're talking about the structure of the atom, in particular, Section 5.4, Light and Spectroscopy. So let's do a little review of the electromagnetic spectrum from freshman year. So visible light, all light that we can see, is only a tiny sliver of the electromagnetic spectrum. So the entire electromagnetic spectrum is light, even though our eyes can't detect it. And it goes from radio waves, microwaves, infrared waves, everything we can see here, visible light, ultraviolet waves, X-rays, and gamma rays. And as you can also see from this diagram, the energy, frequency, and wavelength of the different types of electromagnetic radiation vary. Gamma rays have more energy than radio waves. Gamma rays have a higher frequency than radio waves, and gamma rays have a much smaller wavelength than radio waves. Let's delve a little bit more into the electromagnetic spectrum. Please write this down. This is the complete range of electromagnetic waves. And we go from low energy to high energy. So radio is the lowest energy, microwaves are next, then infrared, visible light, and visible light goes from red, Roy, GBIV, has the lowest energy, and violet has the highest energy, so red, orange, yellow, green, blue, indigo, and violet. And then ultraviolet, X-rays, and gamma rays have the most energy. So we are surrounded by the electromagnetic energy. Cell phones, here's an older cell phone, are used, they use microwaves. Radio waves use microwaves, and obviously visible light uses light. So white light from a lamp or the sun is not truly white. If you were to take some white light, maybe from a star, and put it through a prism, it would break it up into different colors. Or if you took white light from an incandescent light bulb, which is just like a normal light bulb, and you were to send it through a prism, it would be, you'd have all these different colors. And if you were to take light from hydrogen and send it through a prism, you would just get certain colors, not Roy G. Biv. You would get a certain line of red, light blue, blue, and violet. So what does all of this have to do with the structure of an atom? The answer is electrons. So let's go back and quick review what we know. So we learned about the atom, Democritus. You can break up an element into its smallest parts until you get to an indivisible part, and that he named that the atom. We learned from the gold foil experiment that the nucleus is small and dense and positively charged. And then also looking at the Pauli exclusion principle, that electrons can only be in one place in like a quantum state. You can't have two electrons in the same state. There has to be something different about them. So I've been telling you all this, but is there evidence for this? Do you have evidence to support all these claims? Yes. And the evidence comes from spectroscopy. So what is spectroscopy? Spectroscopy is analyzing matter using the electromagnetic spectra. And often we are analyzing things in the ultraviolet, infrared, or visible light spectra. And every element in every compound has a unique spectrum. So spectroscopy can be used in many ways, many different ways. I will give you just two of them. You can analyze the elements in stars by doing spectroscopy on the light from the stars, and then looking at the unique light that comes off of that, you can figure out which elements are in that star. Another example is to identify an unknown compound. Perhaps there was a compound at a crime scene, or perhaps you are creating a new drug, and then once it's created, then you'll have it go through spectroscopy to make sure that you created the thing that you were trying to create. So when you are looking at the drug in spectroscopy, it will give it a unique spectrum, and that'll tell you the different elements and different bonds that are in that compound. So looking at this picture, each type of atom has a different electron structure because each element has unique energy levels, just like a fingerprint. So spectroscopy can be used to identify elements just like a fingerprint can be used to identify people. If you see lithium has a different spectrum than carbon does. So if we were to run some tests and we got this spectrum, we would know that it was lithium was in it, and if we got this spectrum, we would know carbon is in it. And if we recall from freshman year, we looked at the spectrum of some different types of light, both of certain elements and then of like fluorescent and incandescent and stuff like that. Let's look at the interactions between light and matter. So the energy levels of the electrons are different for each element, because we know each element has different numbers of protons, and if it's neutral, it has different numbers of electrons. So they're going to have different energy levels. So bear with me here. Light passes through an atom if the photon, which is a little packet of light energy, has the same energy as one of the electrons. The electron absorbs the photon and jumps up in energy level. So please write that down, and then we'll talk about it in a minute. Later, the electron emits the same amount of energy as light and falls back to its original energy level. And again, please write that down, and we will talk about it when we look at the picture. The color of the light emitted depends on its energy. Okay, so let's take a look at the picture. So why does the atom absorb only specific or discrete energies? Remember, only certain energy levels are allowed. You can have an electron here, or you can have an electron here, but electrons never exist here. So the energy of the photon matches a gap between the levels. So if the amount of energy coming in is the exact amount to send this electron up one level, then that energy is absorbed. If it is not the same amount, let's say it's a little bit bigger, and it would be like from here to here, well, the electron can't be there. It can only be here or here. So then that light just passes straight through. So when the energy is absorbed, that's a certain amount of energy, that's a certain wavelength, and each wavelength corresponds to a certain color. Like this amount of energy in this wavelength would correspond to this red. So hydrogen atoms can only absorb and emit light of very specific energies. So when the photon comes in, it excites the electron and it goes up a level. And then we know that electrons always want to be at the lowest possible energy level, so then eventually it's going to fall back down. It's going to fall back down and give off a very specific amount of energy, which has a very specific wavelength, which is a specific color. And then this electron, a different photon had more energy and excited it up to here, and then when it came back down, it gave a blue-green amount of energy, wavelength, color, and then a different photon had more energy, and then the electron was excited, it came up here, and then when it fell back down, it gave off a blue-violet light, and this electron was excited by a different photon which had more energy, and when the electron fell back down, it gave off a violet light. So that is why hydrogen only gives off a red, a blue-green, a blue-violet, and a violet, and no other colors. So if you had a spectrum card and you're looking at helium, you can see helium would have different colors. They'd have a red orange, a yellow, a couple of greens, and then several blue and blue-violet and violet. And also, if you see, here is element 1 and then element 2, but if you had a spectrum like this, you could tell that this star or medicine had these two elements in it. So that's how you would do identifying what compounds or elements were in the light from a star or a drug. So the energy, we talked about this, just a quick review. The photon comes in and the energy of the photon matches a gap between the levels, and then the photon is absorbed, and then when this electron isn't excited anymore, it falls back down and it gives off that same amount of energy, and then this red light is emitted. And so things are absorbed and then they are given off again. Excuse me, they are absorbed, the bottom one, and then they're given off again when the electrons fall back down. So each type of atom has a different electron structure, and each element has a unique energy level like a fingerprint. Just like we talked about what happened with the electrons going up and then falling back down and why they give off certain colors. So speaking of colors, we were talking about chemistry and fireworks in that last section, and you make sure that you reread that and be able to talk about that in class. And that concludes our notes for Chapter 5. All right, good job.